Good morning, everyone.
Good morning.
My name is Masahiko Murata, the Director of Safety Management, Research and Education Center. I used to work for the local government, or Hyogo Prefecture government. In the year of 2017, on the way back from to Japan, we had a city tour in Kuala Lumpur. And we happened to pass by the smart tunnel, this one. The tour guide said, this motorway tunnel is used as a flood water tunnel when heavy rainfall occurred. But I felt, is it really? This motorway has many road signs, lights, ventilation fans on the ceiling. If it is used as a flat tunnel, they will be broken. So I plan to visit this smart in the early 2020, but because of the COVID, it was canceled. On the other hand, in the year of 2018, in Tokyo and all around Japan, we had a very serious flood, and so-called GCANs, Tokyo Metropolitan Outer Area Underground Discharge Channel, very long name, so-called GCAN, giant cans, worked very effectively to prevent flooding around Tokyo area. It is known as underground temple or chikashinden in Japanese. These are the background of the study. By the climate change and global warming, the heavy rainfall increasing. And due to of cutting trees in the forests, water come down to rivers very quickly. And due to urbanizations, the ground surface is covered with asphalt and concrete. And the underground infiltration rate decreased. And drainage facilities are inadequate. In this situation, the risks of water disasters in urban area is increasing. These are the usual way to reduce flooding. Deepening and widening rivers, or raising levees or dikes or river banks, or strengthening the river banks, and the installation of drainage pumping facilities, and so on. This is usual way. And this is a very comprehensive, all-basin targeted method, such as conservation of paddy fields, forest conservation, and land use regulation, and constructing of dams, reservoirs, etc. And this is the point. Discharge channel construction beyond basins. This is today's target of my research. For that purpose, Malaysia has this smart tunnel. Full name is Storm Water Management and Road Tunnel, called Smart Tunnel. It was established in 2007. The length is about 10 kilometers, and half of the tunnel is used as a motorway, and the diameter is about 11 meters, very big. And Tokyo has GCANs, Metropolitan Outer Area Underground Discharge Channel, established 2006, very similar. And the diameter is 10 meters, very similar. And the length is 6.3 kilometers. Japanese friends may know chikashinden. This is not the chikashinden. This is only a tunnel. But a part of this GCANs, we have chikashinden. a water tank, a pressure adjusting water tank, or working as a reservoir. Length is 77 meters wide, similar, and height twice this classroom. Very large empty floor. There are many columns. This is a comparative study of these two large urban infrastructures. The common keyword is discharge flood water beyond river basins, not a bypass in the same basin. Connect from basin A to basin B. This is the point. Most Malaysian people know the SMART and its operation. The objective of SMART is to reduce the traffic congestion in the city center area, and at the same time, or sometime, used as a flood protection discharge channel in case of large rainfall. The logo mark of Irrigation and Drainage Department of the Government of Malaysia shows this tunnel has 3 decks. This is the logo mark of the SMART. The lower deck is used as a water channel, and upper 2 decks for motorway. The location is just like this. This is the central place of Kuala Lumpur, and from upper area of Klang River, SMART tunnel starts and connected to the Kerayan River basins as a water tunnel, and partially motorway. Usual bypass connects from upstream to downstream, passing by the busy area. But SMART connects this basin to another basin. This is the point. This is another map. Half of the SMART is used as a motor tunnel. Total 9.7 kilometers and diameter 11 meter, and motorway 4.7 kilometers. And the water that fell upstream of Klang River will not pass the central place, but discharge to Kerayan River basin, just like this. Before the tunnel, it has a reservoir. And SMART is operated in 4 modes. Mode 1, no stream. 2 decks are open to the traffic. And mode 2, still in the lower deck is used for the stream. The flow rate 70 to 100 cubic meters per second at the upper stream. And mode 3, the rainfall continues. The upper deck motorway is removed, the gate closed. And if the rainfall stops, the motorway will come, cars will come back. But it prolongs, and level 4 will be issued. When it exceeds 150, whole of the tunnel, together with the motorway, is fully used for the drainage. When I started this study in 2020, there was no evidence of its actual operation. But September 2020, I finally found the evidence. Such report and movies were published on the website of the government of Malaysia. And 3 million cubic meters water diverted, just I mentioned. And next year, 5 million cubic meter water was also diverted. And this is the actual video. I hope it works well. Water come into the motorway, and the water level increase. Oh, completely covered with water. And from opposite way, please see this road signboard. Immediately folded down. It's very well designed, but after this motorway used in this way, so many debris come into, and it destroy road signs and lights and many road facilities. I'm afraid it takes several days or a month or so if it is operated in the mode 4. It takes time, but it works very effectively. And the time is so limited, so I'd like to move to GCANs. This is our main point. Only 3 minutes, I will rush. Around Tokyo area, Nakagawa Basin has a ball-shaped low ground level area and very prone to flooding. And GCANs discharge the water in this Nakagawa Basin into Edogawa Basin area. So GCANs is composed of 5 can-shaped pits and underground tunnel, and at the end there is a pressure adjusting tank, so-called chikashinde. The shape is just like this. The effect of this GCANs is very high. After the partial completion in 2002, in these 20 years, the effect is estimated to be 150 billion yen, while the construction cost is 230. So already 65% of the construction cost was paid back by the effect of its operation. The rainfall increased 10% in these 30 years, but the flooded houses number of flooded houses in Nakagawa Basin decreased, 90% decreased, wow. Very drastically. Wow. The GCAN system can discharge 30% of total of rainfall. Additionally, it has a museum of this GCAN system. And this is a comparison chart between Malaysia and Japan. A common concept is underground channel beyond river basins, contrary to the characteristics of natural water itself. Water runs from higher to lower, but this system moves water from lower to higher. And the difference is just I mentioned. The dimension is similar, but SMART is a motorway usually, and generate money every day. 3 ringgit per 1 car. Only small cars, not a dump truck or large buses. And mode 4 activated 80 times, only 8 times only. While GCANs worked 71 times because it is originally a water tunnel. And this is the conclusion. sorry, 1 minute overpassed. SMART and GCANs are both national disaster risk reduction projects with huge investment. General public knows the name, you may know, SMART, but not well recognized its actual function. Even in the event of a disaster, if damage does not occur, they are unaware of its existence. However, as the frequency of heavy rainfall increases by climate change, gradually recognize their importance for flood, DRR, and they were widely reputed. And besides, reduction of life-threatening dangers and increased sense of security for residents around that area may said to be uncountable effect. So considering the construction cost, operation cost, profits, and the effect of prevention flood damage, the SMART and the GCANs may be evaluated as a good example of urban DRR infrastructure with extremely high cost performance in the long term. And we will visit the SMART the day after tomorrow together with UUM teachers. Thank you very much.
Thank you very much, Professor, for that presentation. So we move along for the next presentation.